A warm welcome once again. Today, coincidentally, also is Valentine's Day. We are competing with it. So, at least people in the room are more interested in spreading the love of 1M to M. So, anyways, I would like to first start by thanking our host, IIIT, for hosting us. And my name is Sachin Gaur. I am the local coordinator for this project, under which we are organizing the series of developers event. And my colleagues here would probably elaborate more on the importance of standards and why we are doing this. And to start with, I would like to invite Klaus Spandl from the European Union delegation to India. So if Klaus, you can elaborate a bit about the context, that would be nice.
Thank you very much, Sachin. Honorable Dean, Rector, thank you very much also on behalf of the European Union to invite us here to implement one of a series of 4 tutorials in 4 different Indian universities and 1 hackathon on Friday in Indian Institute of Science in Bangalore. So I will be very brief just to explain that this is an initiative which is implemented, which is organized under an India-EU cooperation project on ICT standardization, a project paid by the European Union, which supports the cooperation between the Indian telecom standards body, TSDSI, Mr. Madan is here, and the European telecom standards body, ETSI. So we have Laurent here, they will both briefly address you afterwards. And they are working together in creating standards in priority areas which we have agreed jointly, which is 5G, machine-to-machine communications, future networks and security. And they do this in the frame of the 2 leading international standards initiatives. One of them is 1M to M, which is Internet of Things standards. The other one is 3GPP, which is developing the 5G standards and security standards. So this is what we do in the project. And as part of this project, we do a lot of things, but we thought it is also important to do an outreach to the developers community. So young people, mostly from academia, from startups, in order to propagate the already available 1M to M common service layer, which you will be told about by our colleagues from the University of Toulouse, CNRS, which came all the way from Toulouse to share this very interesting knowledge with you today. So why, just one last word, why does the European Union get into doing something like that? Well, the first reply is because it's highly enjoyable instead of just dealing with companies and so to go to a university for a change. But the real question is that the European Union is a very strong believer in standards. So we support standardization within Europe, but also with our key partner countries worldwide. Because standards are good for everybody. Standards are good for companies. It makes their life easier to export, to create networked value chains across borders, across economic sectors. It is good for the consumer. It creates trust. It creates interoperability of devices, of applications. And it's very good for governments in India as well as in Europe, because you can use standards to increase the ease of doing business. You can use it for light touch regulation. You can make your consumers happy if their devices work everywhere. And last but not least, among the companies for startups, it is a very important, I call it innovation platform, because it allows, with a minimized risk, it allows to produce apps, produce services, products for a big audience without having the risk that you bet on the wrong platform, because it works on basically everything and worldwide. So this is what we do. So I wish you a lot of enjoyment today, and I hope you profit a lot from what we are trying to do. Thank you very much.
Thank you. So thank you, Klaus, for elaborating. And as you can see on the slide here, the project website is indiaeu-ictstandards.in. So if you want to know more about the activities, you can visit the website. And now I would like to invite Laurent from HC. If you could say a few words about HC and your cooperation here.
Hello, everyone. So my name is Laurent Velez, working in ETSI, the European Telecom Standard Institute. So we are in charge of the standardization in different domains and different technology on telecom, mainly on telecom. So we are also part of the 3GPP partnership project, and this also this 1M2M that you will hear about. So that has been a very innovative initiative with the 8 main standardization body in the world to create this, let's say, 3GPP of the object, of the connected object. So we wanted to have a common architecture, a global vision of the Internet of Things that can manage all the IoT domain. So we didn't want to compete with the other technology. There are many protocols, many technology. It was not the goal to add another technology. It was to have one common framework that can apply to all independently of the protocol. To have a common framework to store the data, to the format of the data, the primitive, high-level primitive, in order to manage all the existing technology and also the future technology. You will see the code that you can write with 1M2M can apply now, can apply when the 5G arrive, and in 10 years you will have the same code, the same way to store your data, to make accessible your data, independently of the protocol that some of them may be deprecated in a few months. So it's a high-level architecture, but it's a common architecture. It was really the vision behind that. It's a long-term vision. So I hope you will appreciate that. Thank you very much.
Thank you, Laurent. Society of India, TSDSI, which is also the organizational partner of 2 of these partnership projects globally, 3GPP and 1M2M. So Mr. Madan is advisor to the TSDSI. So.
Thank you, Sachin. Good morning to all of you, and welcome to this event. And we are very delighted to be here, courtesy our host, Professor Narayanan and his colleagues, my colleagues from HC, and Klaus, who is behind all those things, Sachin, my friend here, and we met last time, the professors from IIT, Triple IIT here. Welcome to you all, sir. Thank you very much. Much has been said about standards and the purpose of this event and the chain of the events which we are going to have. I'll get an opportunity for a couple of minutes to explain to you what TSDSI is, because other things have been already said by my colleagues here. TSDSI is a standard development organization of India. We are a society supported by 50 members of telecom fraternity, including vendors, international vendors, including service providers, including academia. And we are now making the outreach to another 50 members, 100 this year. And we are also partners of 1M2M, for which we will be talking today. We are also partners of 3GPP for 5G and others. We have done, in last 1 year, we have developed some contributions to be going back to 3GPP as Indian environment and environment of countries like us. We have one of the achievements which we have done is that in 5G, normally they were considering small cells, and now we have made a proposal for larger cells because of rural and sparse population in India, and it has been accepted there. For last 1 year, Government of India has tasked us to develop security standards for interoperability of cloud and portability of cloud services and all. We are also been tasked by government to work on security standards for safe to connect telecom networks and services. And we have written about 295 documents of 3GPP, transposed them. We have transposed 27 documents of 1M2M, and now we are working on security, energy efficiency, and also on interoperability standards of Internet of Things, smart cities. And in India, we have also partnership with BIS, Bureau of Indian Standards, and other Telecom Engineering Center, and MIT and DOT, apart from industry and so on. So we are proud to be partners of all these, and we are very happy to be coordinated with this effort of spreading awareness. One thing, last thing I'd like to say is such standards, we are working on pre-standards in terms of white papers, reports, exploration studies, awareness studies, and we are working on standardization and we are working on post-standardization. Once the standards are implemented, what should be the best practices, what should be the rules for making them all that. Advantages, my colleague has already told you. Last thing I'd like to tell you is that for standards and interworking, it is very important that we work in a collaborative model. And this is where we are here in institutes, we are here with new innovators, startups, large industry, small industry, so that everybody is easy and consumer gets the benefit. Thank you very much and God bless you all.
Thank you. Thank you. So I would like to also share with Director today that last night we were having interaction with 3 of your colleagues, with intervention of Sachin Chaudhary, our host. And I think it was a very enjoyable conversation we had with Professor Vishal and Ramesh. So they told us about the smart building and all the other work that you are doing here. I think IIIT Hyderabad has made its own name, and I think I've been told that you have a very different kind of culture here. It's a first name culture. So I feel very happy because that's the start of the innovative ecosystem, and I think T-Hub is very well known throughout the country. So this institute is definitely very special. So without further ado, I would like to invite Director PJN, as I've been told that's how people call you here, to say a few words.
Good morning to all of you, especially the delegation from EU. Thanks for coming all the way to India and all the way to our campus for conducting this. So IIIT is a we like to think of it as a new age institution. It's a full-fledged university, but started in 1998, which means for a university it's quite young. But the critical difference is this, in most of the institutions that you see in the country, the IITs or the IISc, they all tend to be completely under government institutions. And the government, like most of the universities in Europe, I understand, government funds all the expenses, salaries and everything. Whereas when this institute was started in 98, it was decided to, the local state government actually started it, initiated it, but they didn't want to give any money, control it or restrict it in any way. So it said you have to run on your own. So that's been 20 years, we are completing 20 years this year. We get no grants from any government other than against proposals to do specific things, but not for the salary, not to pay the bills, not to do any of those things. So that's this model is not very common in India. Universities which are outside the government system is not unknown at all, private universities, but universities which are also fully research focused, just like any of the institutions in any of the IITs or IISc or the universities of the West, doing the same thing, not just doing only teaching. Outside of the government sector is rare, and we like to think of our model to be similar to the private research universities of the US, very similar to that, completely society driven. We like to think of ourselves neither private nor government, but public driven, which means we need to be connecting with all kinds of entities. So industry, we have strong relations with industry, with government, with other academia, and playing a larger role in the society. That's something that we would like to do, because that's the way we connect ourselves with the society. And I'm glad to see this standards body, a tutorial or exposition about standards process and standards being done here, because this is not something that neither our students nor faculty or researchers think is in their purview. Academia is, at least in India, I don't know how it works in India, missing in this process of standards. I know we have a couple of our, one or two of our faculty members are in some standards committee on education or something in Delhi, and I just got a letter from last week saying you have 2 members but they never attended any meeting. This letter just came yesterday, last week sometime. So, I think academia doesn't think this is, somehow they don't connect with these things. We connect with teaching, we connect with the research and a few other things, but not these things. So, I hope, some of this, your session will at least enlighten some of the people here that this is also important to have the entire ecosystem working together. You can have your own, great ideas, but unless others, you can operate with others, your ideas will stay on your laptop or your garage. It cannot go out. And how complex and how hard fought these things are, the standardization, especially companies, I'm sure they're into this with multiple interests. So that's why academia, it's important for academia to get into this. And so I'm glad this thing is happening here. I thank Klaus and Sachin and the team coming here, as well as our own Sachin for doing all the groundwork here. And enjoy everybody to enjoy this session, and hopefully you'll all be more enlightened after this. Thanks.
Thank you for the kind words, sir. Maybe a small request if you could stay. So, Klaus, could I request you to, on behalf of EU delegation. Klaus, if you could stay. Can I also request Dean Academics if we didn't get to hear from you, but we value your presence here. Maybe later you could take cognizance of what are the future collaboration possibilities with both sides. So with this, you want to say something?
Yeah, thank you, Professor, for remarks. But I'd like to clarify that academia is very actively participating in standards now. We have from IIC, IIT Delhi, IIT Madras, IIT Mumbai, IIT Hyderabad, and to your surprise, the maximum contributions have been given by academia because innovation is thing which starts the standards, and also the intellectual properties and other things and all that. And academia is a major contributor, and we'll invite IIIT Hyderabad to be collaborating with us and through the world. Thank you very much.
So with this, I kind of formally conclude the inaugural part, but now we have the real rock stars of our day today, which is Professor Thierry Montel and Professor Samir Medja. So I think the program now begins. Maybe we are running a bit late, but I think we will be able to make up during the day. Thank you very much. So over to you, Professor Thierry.
Thank you. Thank you for this invitation in this university. First, I will just show you what we can do with standardization and with standard that we will present today. So it's a project made by a student at my university. So they deploy some things, some sensors, some activators inside a flat in a smart building. They have done this project in around 30 hours of work. No. So the goal is to make automation inside the building. They created tools that you can configure. Then you can manage a different event inside the house. So for example, when you go to sleep, okay. So the system detects that you have put the book, and you can switch off the light. So this is a typical scenario where standardization can bring you something. You can use the same sensor to manage light, to manage heater, to manage alarm. You don't need to have one sensor for everything what is used to do now. If you want to do that in a smart home, you need to buy a different system. But with the standardization, you can have only one system and all the house is managed. So now, today we will talk about the presentation of 1M2M standardization. This standardization is developed since several years now. Just a few words about my university. I come from Toulouse with Samir. Toulouse is called the Pink City. It's quite an old town in France, and a very active city. Toulouse is part of a state called Occitanie, and it's the first region in terms of research and development. This is due of the presence of Airbus Group in the city, and some other company on IoT and also on network. It's also the second university in France, and we have some exchange with India, in cooperation with India. So it's a very dynamic region. So Toulouse is in the south of France, and from now we have some snow. I come from an engineer school called INSA. INSA is deployed all around the France and also abroad. And we have 40 different engineering training fields in computer science, in biological, in civil architecture, in electronic, etc. Samir and myself are from the Laboratory of Analysis and Architecture of Systems. It's a laboratory of CNRS, and we work on different technology on IT. So we work on crucial computing. From Samir and I, we come from a department called Network and Communication. And also in the labs, we work on robotics, energy management, micro and nano structure. So now I will start my talk. First, I will give you some information about interoperability and why we need standardization. After, I will go deeply in 1M, 2M standard and show how interoperability is very important and how we can decline in several types of features. I will give a few words about security and a few words also about data management, which is, in fact, an important part because we will make business with data. If we have a quick look of evolution of the web, in 1906, we have the starting point of internet on web with the development of website, where most of people only read information from the website, and a few people put some contents on the web. In 2006, we have the web 2.0, where people can put some data. It's a creation of blogs and all of those things, where people make data, people can read it, and exchange about everything that are interesting for them. Now, even if the term is not accepted by everybody, we can give this name of Web 3.0. In fact, it's a mix of several types of web. We have some programming web, where we can have some API and make an exchange with the web. We have the physical web, where we could connect equipment and hardware and make an interaction with those equipment using a web. We have also some web where we want to have real time, so the time is crucial in this web. We have also the social web, and I'm sure as a student you use Facebook and this kind of networks, and it is used in a different subject. And also we have the semantics web, where we want to have an intelligent and smart web, where we can request with a natural language, for example, to get information. And in fact, you can see Internet of Things as a mix of every those webs, where we need to interact with physical world, we need to program, we need semantic, and we need also some social. For example, Nokia have made a product where objects can be friends of other objects, and they can interact when they are friends. If I take a definition of Internet of Things from UIT, it's a global infrastructure for the information society, enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technology. So in fact, the main point of this definition is that you need a network of networks. So it's not only one network, you have several and plenty of networks that must communicate together. You can use a wire or wireless network. Also in this network we will have physical things, so a sensor, an activator, but also some virtual entities, like a group of sensors, it's a virtual. And also we need to address all of those equipment, all of those entities, and also the contents. So it makes a problem of addressing all of those things. In terms of potential, we are in the hip of these curves. It means that everybody thinks there is a lot of potential. There's a lot of opportunity to make IoT and develop new services and functionality. And We'll go down to the production very soon. So it's a good point to go in IoT and develop activities on IoT. In terms of things, we are around 10 billion to 15 billion of things. And in 2020, we are around 25 to 49 billions of things. And in terms of business, it's between 1.7 to 13 trillions of business. So it's a very important growing of business in this domain. With this picture, we see in a lot of presentation on IoT. We can't see everything on this, but we can imagine the different domain on all the things that we can do. In terms of domain, so we can work on building, energy, retail, industry, health. All of those domains are needed to use IoT and to make new services, new applications, new devices to be ready for customers. Just a use case for fixed IDs. It's a use case on smart metering. So in this use case, we have some home, building. They have some sensors and activator inside. They can produce energy. Those are connected to a wide area network, supervised, and all this information are sent to a data center. We have also a provider of energy that also monitor his network to know what's happened on the network, all the products have been done, and also all this information are collected in the cloud. With this type of architecture, we can build new functionality, and people want to do some new services. So first, it will be easier to have an information about your consumption of energy because you have some smart meter inside your house in terms of energy, in terms of water, gas, everything. With this communication system, the provider can also do some management in your house. So you can do some update of firmware and get information to optimize the use of the network. It can also produce some new functionality in terms of prepayment. So you can imagine that you will pay, for example, $30 to get energy. And when you use energy, you will be this money will be decreased, and when there is no more money, the electricity will be cut without any action from physical people inside your house. It's not very good for customer. You also will have some many tariff in terms of price of energy. I don't know in India if you have different price, depend of the day, or depend of the time in a journey. But in France, for example, we have two different tariffs. So it could be cheaper at the certain times. So when it's cheaper, you need to use more energy, for example, to do the washing machine or this kind of things. And in other countries, for example, in Canada, you have also best effort energy. So you can pay very less and allow the operator to cut energy if you have some problem of his network. So it helps to cut all the heap, and it's better for the energy management of the operator. You can also have some display, so many more services using sensors and communication and cloud. Another use case on which we work with a different company. The goal is to make new services for connected vehicles inside the city. So in this system, we collect information from sensors inside car or inside the city, but also we collect information from government, environment government, security of the city. And with all of those information, we create new services for emergency vehicle, for example, to prevent and say other vehicle, be careful, there is an emergency vehicle will arrive near you, so go slowly and be careful. We can also new services inside the bus to have, for example, specific information for user when you go near a shop, and the shop can send an information on its smartphone, say, well, you are in a bus, and in 2 minutes you will be near this shop, you like this shop, and now we have a discount for you. So this is the kind of things we can we try to do in a new system in the city of Bordeaux. In fact, in all of the systems, This is the same architecture. We have some sensors, different type of sensors. If you are in a house, we can have a KNX sensor, Zigbee 6 sensors, on different technology inside the house. All of those technologies are connected to a gateway, a box, if you are with an operator. And this gateway will communicate with a cloud, with a wide area network. And all the applications are built on the cloud. So when you want to interact with the sensor, you go through the cloud gateway and then activate something in your house. So this is a common architecture in industry. We can do some simple architecture, we'll see later. The problem is when you have a look on a real system, for example in a bus, you have more than 6 different type of system. Each system has their own sensors, their own gateway, they pay their own communication operator, and then send information in a company, in a cloud. So when we want to make interaction between systems and use sensors or of other systems, we need to make connector. So a connector with this system, with this one, with this one. So it make work, we need to develop this and to know the technology of each other. And when we want to add a new system, we do the same, create a new connection to everything. So it takes time. You need to have some specific skill inside your team to do that. And in fact, it costs a lot. So this way of thinking about system is not very good in terms of development, in terms of new functionalities. If we have a look on the potential of cross-domain things, so how we can develop application between all of those domains, we see that we have a growth of devices more than 31% between last year between 2016 to 2017. And if we have a distinction between vertical domain and vertical specific sensors, we see that the growth will continue. But if we go on a cross-domain sensors, we see that the growth go faster. And in fact, in 2020, there will be more devices used in a cross-domain than in a vertical domain. So we need to be prepared to this because the business is here. This is another more detailed view of these things, depend of the domain. And we saw, for example, in factory, it's very important that the value, there is more than 36 more value in the domain of cross-domain. And in fact, around 40% of the business will be done in cross-domain in the future. So we need to do that and address this problem. But it's not very easy. When we have a look on standardization, for example, we see that depend of the standard, depend of the domain, we have different standards that have been done. So if you are in a home building, if you work on, for example, on energy, you use Senelec standardization. If you go on a city, you will use another one. And also, depend of the level that you consider, you have a different standard also. We just to take again the common architecture with the sensors, communication, and application level. So if we go in the device domains, we see that we have different type of standard, for example, Bluetooth, Zigbee. And the goal for this kind of standard is to make connection, to address the connection between a device and the network. If you go at the level of the network level, the goal is to, in the future, to address the different characteristics of the traffic that IoT will make on a network. So this is the goal of 3GPP, for example, the creation of 5G, to see what we can do with this specific traffic, how we can address quality of services, different bandwidths, and this is work also done by the different standardization organism. Then at the level of application, the goal is to have interoperability and to try to have a cost-efficient development solution. There is also a cross-domain C to see how we can build common services from devices to application and in the different level. And that's the goal of those kind of standardization organization, TDAC in India, HC in Europe. So they have tried to create a common way to see all the services necessary at the different levels of an architecture for IoT. And the goal is to provide an horizontal view, an horizontal IoT service platform with a generic service capability to help and to create IoT interoperability between all the domain, all the sensors. So they need to be connected to multiple communication protocols. They need to reuse as much as possible what have been done in previous. So to be connected to legacy devices, to already done standardization developed in an industry, and make an interworking with vendor-specific or any type of devices. So the goal is to break this view of a silo of each vertical domain to create an horizontal service architecture where an application can go take an information from these devices or from these devices with a complete transparency of development, of use of all the sensors. So this is the goal of 1M2M standardization. The partnership have been created between several types around the world of standardization organism. Just another view. So this is the first partnership. There's also a connection with other standardization in another domain. They have made also connection with other standardization in IoT. So there's several standards that work also on service for IoT. So 1M2M have done connection with those. And also they share the specification with other organisms to have a very worldwide use of standardization. To do that, they organize a different community. The more important things is to see that there is some working groups. So it's a top-down view. First, they have a look on different use cases to see what is common, what we need in different domains, in energy management, in smart city, in vehicles. And then they have built architecture, protocol groups, security, management, and also testing to see if everything is interoperable and everybody can work together. So this is a good point of 1M2M. It's a worldwide standardization. So if you develop something in India, it will work also in America, in Europe. The same standard is used everywhere. There is a first release in January 2015. So several documents have been written in terms of requirements, architecture, service, connection with different existing protocols, security. And also the good point is that all these documents are free access. So you can download, you can see the draft, how people work, what will be the finalized document. So it helps you to think about what will happen in the future and what you can do. So you can go on the website of 1M2M and have an access to all of those documents without to be a member of 1M2M. So the goal is to address several domains, and 1M2M try to make a proposal of architecture where we have communication networks, we have the hardware part with data processing and protocol, and we want to build this service layer and create an API for every domain that can use this kind of architecture. If we go deepest, so we saw the different architecture, different layer. The first one with the network layer, service layer, and application layer. This is really a telecommunication view because most of industry that are in the standardization in HC and TAC come from telecom system. So we saw that they define the different interface between all the elements. So at the network layer, we have the network service entity. We provide service for the network, to access to the network, some specificity from the network. We have a connection with an interface called M2M communication network, and we go on a service layer with an entity called common service entity. Then we can deploy application and connect with the M2M communication application interface. This is a distributed system, so we can also make connection with the other element connected to the network. So there's different common service entity, and we have here an interface between both systems called M2M communication common service entity. We also need to deploy on a real system. So we deploy on devices or a smartphone, for example, a system called application service node. This is a type of one type of node. We have also a middle node. This is deployed most of the time on the gateway. And also we can have an infrastructure node deployed on the cloud. So we can deploy a large, very large architecture and also a small one we'll see later. They also define a connection between different architecture. So we can also make a connection between different infrastructure nodes if it's necessary to do that. So we can deploy an infrastructure on the city, but you also can have on another city and make communication between both systems. Just an example. So we want to make what they have done in the video. So we have some sensors in the building. You have a gateway. And we will deploy on those gateway different services and applications. So on the gateway, we'll create a common service entity. And for all devices, we'll create an application entity. And this application entity will be run and declared on the CSE to get information from this device. So it's a part of code that get information from this device, some request, receive a notification from the devices. If we want to develop an application also in a smartphone or a specific application or a gateway, we'll create an application entity. On your smartphone, if you want to connect to the gateway and interact with a specific sensor, we also have an application entity. This is a way to represent what is necessary to communicate with your smartphone. So this is the simplest way to deploy an architecture of IoT. If you want to have more complicated architecture, you can deploy also a cloud part, and then we'll have several common service entities that can communicate together, and we have the kind of architecture that an operator, for example, will deploy with an access with your smartphone to the cloud. The cloud will communicate to the gateway, and the gateway can interact with your home anywhere. So we see application dedicated nodes, middle node, infrastructure node. So this is another part of the standard. Now we have a common architecture. We can talk together all around the world. We know what we talk about. This is a standardized architecture. After that, they deploy some services. So they propose a different kind of service. The first one is registration services. So when you connect a new devices, it needs to interact with the architecture and say, well, I'm devices, and I can connect with you and discuss with you. After that, you can create security to know which user can connect to the application and to the system. You can manage communication with different type of communication, request response, publish subscribe, notification. So all the communication patterns that you need in an application. You can make some device management, some group management also, and you can store and get information and also make accounting and charging to make a business behind. So all those services are necessary in IoT architecture, and they have been defined in the standard. When you deploy an architecture, we see at the end, application node, middle node, infrastructure node, and all those services can be deployed or not. Depending on what you need, you can deploy a specific service on a node or not. You choose, you may configure these kind of things, depending on the possibility of your devices on what you need in your application. You also have an important part that I will talk later, called an interworking proxy entity. this is a way to connect a new technology in your system. So you need to prepare that the system will evolve. You will need to make a new connection with new technology, and the standardization I've prepared to be to do that when it's necessary. So now we have also a set of standardization in terms of services after the architecture. We need to interact with the services. So to do that, one M2M architecture is based on a REST architecture. So all the things represented in a one M2M is the resources. And all the resources can be accessed with the URI. So it's very common to do that. You used to do that when you use a browser to navigate on the web. You used to use this kind of address. So to make a change with the resources, with the things, it will be the same. There's also good things with the REST architecture is that you need only 4 different operations to manage everything. So you need to create the resources, you need to delete the resources, you need to get information about the resources, and you need to update the resources. And with only 4 operations, you can do everything in all things of all sensors, all activators, all representation inside one M2M. So it's quite easy to learn and to manage the API. You have some different representation of resources, and you can use also different format, XML, JSON, which is common in a web architecture. The other good things, it's that all the resources are linked together. So it's a way that you use also web. When you connect to a website, you discover what you can see in this website. So it's the same in IoT. You can connect to an architecture, for example, this university, and say, well, what can I do in terms of Internet of Things in this university? I saw there is a room, an amphitheater here. So I go in this space, in this room, and then I can say, well, what can I do in this room? I can switch off the light. This is the same with IoT. It's the same with the web. You go in a browser, you click on a URI and go in another page. It's the same with one M2M architecture. You can discover what you have in this architecture. So it's a good way to have a dynamic architecture. If you add something in the architecture in terms of new sensors, you can discover these sensors and add it in your application dynamically without need to develop a new code if you take care of this. So it's a natural way to use a system with a very dynamicity and systems that can grow very quickly. So in one M2M, the first resources that you have on hardware, on an equipment, is called CSE base. So this is a common service entity where we will have all the resources in a specific equipment. Then we can create application entity. So application entity is necessary to get information from a sensor. It's necessary also to have information on applications that have been connected to your system. So everything is based on application entity. Under the application entity, you have a container. So it's a way to group a set of information that are connected together. And inside the container, you can create a content instance. If you have an update of a value, you keep all the history of the values. So you can get the last values that have been recorded on the system, or also an history if you want to make a data analysis, for example. So everything is connected. You have always a list of childs, but also the parents of the resources. So you can navigate in this resources tree very easily by make a connection, a REST connection, and REST API, using the REST API.
What is the CMD and container and what exactly the information?
You can put what you want. So in a container, you can declare several types of resources. So it could be a text, it could be a value. It's
basically A is like one sensor node.
So
Maybe one A is like a sensor.
yeah, it could be a sensor.
Sensor will have only the sensor information. How can it again into some other data? I cannot get it. Basically A has some sensor information, right?
Yes, but also some application, you can have some user information, you can have also some write information, you can have some localization information. It's totally free. It's only a box where you can put data.
AE gets connected to CSC, it's not via REST concept. Because if I want to connect to my gateway, CSC is my gateway.
Yes.
If things like my AE is not having any Wi-Fi module or it doesn't have a GSM or carrier network, it has to connect on BLE or something, then I cannot use REST, right? Okay. So this is difficult question.
Go, sorry.
I'm sorry for that.
No, it's okay. We interact. We both respond to all the questions.
It's just a representation of the system. This is not
The code.
an application in software engineering. Just a representation of a device of another program, etc. So this is just a data that is stored in the database located in the gateway.
For example.
How is the gateway seeing the system?
For example, you will have the IP address of a devices if it's IP devices. So it's only information to know how to communicate with this specific devices. This is not the code that run on the devices. Yes, it's true. Yeah, no, good. Feel free to ask any question. Okay. So we can communicate with different protocol. So we can use HTTP, COPE, if you are in a constrained domain with a problem of bandwidth and size of packets on the network, you can use this kind of protocol. You can also use MQTT, which is a publish-subscribe protocol, and also WebSocket. If you are more in a developer of web application, you can also use this kind of protocol. So depend of what you want to do, depend of the resources you have, you can choose different protocol. And it's also quite easy to add new protocols if it's necessary. To address specific resources, there's two kinds of naming. The first one is called hierarchical naming. So first, on address, you have a tilde to say it's a 1M2M architecture. Then, if it's hierarchical naming, you have two resources, the CIC ID and the CIC name. To say, well, I want to communicate with these devices, with this part of the network. And then the resource name depends on where you are in a resource trees. You have also, so an example, I'm a 1M2M, I go in the infrastructure node with this ID, this name, and I go in the application entity number 1 and take information in the data container. You also have non-hierarchical naming. So in this address, you have arrays tilde to say I have a 1M2M, it's a 1M2M address. And now you go directly on the CIC ID and the resource ID. So it's quite a short. If you have a very constrained network where we can only send a few hundred of octets on a request, you need to have very short. It's not very usable for human, but it's good for machine to have a short resources. So depend of what you do, you can use long or non-hierarchical addresses. The system will understand both. So this is an example in CSE. You have this kind of number, and the 1M2M architecture provide you a unique number to address every resources connected in your system. The next things you need to communicate is to have the address of a specific element in the network. So it's called a point of access, and you can have several points of access in the same devices if you are connected to several networks. And you need protocol, IP and port, for example, an IP protocol. So another good point in 1M2M standardization is that it could hide you that you work on a distributed system. So if you have an application, a system made with one infrastructure node and several gateways, several middle nodes, in fact, when you are a customer, you send a request to the infrastructure node. So you need to communicate with this part only. And after, the system can do a redirection to the specific middle node that you want to connect it. So if you can't connect directly to the MN, you can go through that on the system. The 1M2M standard will allow to do that and do the redirection. We can also change protocol. For example, here we can communicate with the HTTP, but between both elements, we don't have HTTP, we need to use CoAP. So also 1M2M will change the protocol and use what you can do to go directly here. And from the customer point, you don't know what's happened here. The system will hide everything in this part. So then the MN can give the answer and give the answer to the customer. So it's always more easy for a user to develop application. He only need to know that he, for example, he need a sensor of temperature in this room. So he will ask this, and you don't want to know how to access this one. This is not the problem of developer user, it's the problem of architecture man. To get a value, so it's a REST architecture, you can use a gate operation, you can use XML or JSON format. So for example, on HTTP, I will put the URI, IP and port number. I will give also information about my access, my right in terms of authentication, and also number of the requests to don't mix several requests, and also say what kind of format I can exchange with the server. Then when M2M architecture will respond to you and give information about the resource that you ask, the ID, the parent ID also, give information about the date, the format of the request, and also the value. So you will see later in the next talk all of those things, and we see the API with the Samir. You can also make an update. It looks like the same. So we create a request on HTTP with the address, the user on the right of the user, what kind of format I will use, information about the node, the resource I want to update, on the value, on the type of the value, and the system will respond to me, okay, I have created a new content instance and stores those information in the system. So you see it's quite easy. All the resources I manipulate with the same way, in the same way, even if you manipulate different type of resources. So just a first example, a short example. In this architecture, we have a smart meter, a gateway, a server, and also an end user with a smartphone. So first, we will start the CAC based on the gateway, so the middle node, and also on the server with the in CAC. It creates a resource tree both. And first thing, they will do some registration. So the middle node will send a request to the server to say, I want to connect to the architecture. And when they've done this, each part will create here an information, a new application entity to say, well, I know a remote gateway, and the gateway say, okay, I'm connected to this server. So now they are connected, they know each other. Then we can register sensors. So to do that, we create an application. In this application, we create two content. The first one is the descriptor content to give information about the sensor. So it's a smart meter. It gives some kilowatt. You have a precision on this. The manufacturer is this one. These kind of things, all description. And also perhaps some information about what you can do with this sensor. And then you create also a data content, data container, to put information about the sensor. So when the sensor will put a new value, you will record this value inside the content, the container here, and create a new content instance. If you have a user that connects to the system, you create an application entity. So you keep information about the smartphone. The address of the smartphone is this one. The user has this right, these kind of things. If you do a subscription, for example, so the smartphone wants to get information for the smart meter, so you do a subscription to be notified if I have a new value, I want to be advertised about this new value and get the value. The subscription is related to the middle node. and we keep an information in the content container here to say, well, if there is any change in these resources, we should prevent this smartphone that there is a new value inside this container. So when a new value is created, we create a new content instance here. This is trigger, and then the information is redirected to the smartphone. And you know that there is a new values that have been read on the smart meter. So now we have standardized resources on API to use any kind of devices. When you have that, after, the next point is to manage the security. So you deploy an application and you want to have a certain level of security. So one M2M have addressed several kind of security problem. I'll just show you a few of them. So first, most of the time you need a secure communications channel. And also you want to have authentication and also to have a management of right on all the resources. So you can use different kind of protocol, depend of the protocols that you use. So if you have HTTP, you can use HTTPS. If you are on COAP, you can use DTLS to encrypt the communication. You have also an authentication. So you have a simple authentication, could be a login password, but you can have also more evaluated way to make authentication with a server, specific server that manage all the authentication. And you use it in a specific header on attribute called XM2M origin. You can also manage the right to access and to modify and to do some action on each resources. So it's based on the access control policy, ICP. So you have a part that tell on each resources what can I do. So this is a call privilege resources, but also you have what we call a safe privilege. This is a privilege to modify the privilege. So if you want to change the right on a specific resources, you need to have an access to safe privilege resources. After, it's quite always the same. You have some binary code to say I can create this resource, retrieve, update, delete, notify, discovery, what action I can do. So if I have any mean, for example, like I have the 63 right, that can make me an access of create and do some other thing. Another one can also have only 34. So you can have a very fine management of right on each resources. You can say this one can do that, this one can do that or not. So this is a part of the security in the standard. There's many more mechanisms, and people are still working on this on Release 2 and Release 3 of 1M2M. To have a very high-level mechanism to manage security, because this is very important in IoT architecture. So now we can deploy, we have API, we know how to manage user, right? So we need to make connection with legacy technology. If you have deployed in this room Zigbee network, want to connect to the Zigbee network and add as a new sensor inside my architecture. So in 1M2M, they have created a quite nice concept called interoperability proxy, interworking proxy entity. So it makes interoperability with a specific technology. So the goal is not to create and reinvent the wheel and make new things about technology. It's just to make a connection between two technology with a proxy mining. So we have an architecture based on 1M2M with a specific plug on the interface to communicate. If we want to add another technology, we just create a unique PU, and this specific services will make a conversion between a specific legacy technology to a 1M2M representation and do the reverse if it's necessary. So it's quite simple. You have your 1M2M system with a different container and content instance. You have your legacy system which monitor with a specific protocol. If you want to make a connection, we create these new services, interworking proxy. So we can get information from the legacy, make a translation, representation on 1M2M, and push on the 1M2M. And if you want to make an order to the specific technology, the same. 1M2M standardization will be translated into the legacy, and you can do that. So when you want to create and make a connection with a new technology, you just need to make this IPA, so one conversion between your legacy and 1M2M. And if you remember at the beginning, when you had a new technology, you must make connector to all the technology. With a standard, you need to do one translation only, and after you are compatible with the standard, and you can communicate with all the other technologies that have been already connected to this standard. So it's a good point for the standardization to have this. So in August 2017, the release 2 have been published. The main point in this release is to have more connector with different technologies. So with another concurrent of 1M2M called Osgi or Iot M2M, but also a connection with 3GPP on 5G when 5G will be deployed. Improvement also with new mechanism in security, and also an important work on semantic. So to know we have an architecture, we can collect information from several technology, we have data, so we need to manage data. In the previous version, for example, in the software that Samir will present you, called OM2M that we work on, we have used a specific representation called OBIX. This is a standardized representation for building, and it's quite nice representation because it's written on structure with XML. So you can represent values that you collect on a specific system with different information on metadata like unit, precision, but also you can explain in this representation what kind of operation you can do on an activator. So it's quite easy to structure information and make an easy way to interact with the sensors and activators. But it's not enough. When you want to make some reasoning on discovery, for example, you want to ask some more elaborated requests, like I would like temperature in this university, but I don't want to know exactly where is it, or it will be represented. I just need to ask this kind of question. So to do that, 1M2M has proposed to use semantic to manage data and make reasoning and interaction and discovery. So the goal of semantic is to transform a raw data, which is a set of bytes that have been converted in a number in a structured data. But what we want to do in a semantic, we want to make knowledge and to know that this temperature have this precision, this is in this place, and the sensor is available, for example. So to do that, we define an ontology. An ontology is a way to structure and to make a common vocabulary. So the definition can be this one. It's a formal and explicit specification of shared conceptualization. So the concept is based on three things. The concept, say, well, I manipulate sensors, measure temperature. The relation between each entity in the system. So, for example, this value is observed on these sensors. And after, you can make relation between between concept using relations. For example, every sensor that make a measure of temperature will be a sensor of temperature. So you can make this kind of reasoning and express more things inside your data and make a more complicated application and useful application. So we need semantic. We need to make sense with data, and semantic is a good candidate on ontology also. So we can make semantic queries with 1M2M. We have what we call a semantic descriptor, where we can connect an ontology and make a mapping of requests on a specific ontology. With ontology, you can also make some connection. So you can use an ontology defined by 1M2M that give you a way to know that there are some devices, gateway, on cloud. But also you can connect a specific ontology on a domain. If you work on smart building, you can use a specific ontology made for smart building. or if you work on a factory of the future, you can also use a different ontology or make connection between those ontology and make alignment to understand each other. So it's a concept used in the web since many years now, and it seems to be the best way to do in IoT. So now you can get data, add sense to the data, and now you are ready to start and create new application. So 1M2M has been implemented in several stacks. You have some open source stack defined by several company or labs around the world, but also you have some commercial stack, so you can choose what you want to do with a specific implementation. For us, we at the last CNRS, we have created in 2012 a software called OM2M that at the first version compliant with a European standard called Smart M2M. So Smart M2M is one of ancestor of 1M2M standardization. And in 2015, we also produced a new stack called Eclipse OM2M 1.0 that are compliant with 1M2M standardization. So OM2M have been selected by the Eclipse Foundation to be one of the software to make IoT. And many company and labs use OM2M because it's free. And also it is based on Osgi architecture. So Osgi is based on plugin, and it's very easy to add new capability on the architecture. If you want to connect a new technology, you just need to create a new plugin, and you can load this plugin on the architecture and have this new functionality. So it's very easy to extend, and that's one of the reasons that people use OM2M around the world. So it's quite nice. You have a standard. You have many different implementation, open source or not. So you can develop your own product and do research if you are a researcher. So first conclusion, standard is very important. It will decrease the cost of development and maintenance. It's allowed to have multiple suppliers. It's very important for a company to be not linked with only one supplier. It's easier for user. You don't need to learn many standards. You can use only one, and after the standard hide you all the difficulties that you can have with a specific technology. Anyway, when you will develop an application on IoT, we will ask you which standard I will choose, because I can take several ones. So sometimes it could be difficult to choose a good one, and depend on what you want to do, you need perhaps another standardization. But 1M2M main point, it's that it involves several standardization organisms around the world, and big university. So you have a worldwide cover of the standardization. It's an open standard, so you can access to all the documentation and learn about it. It's not true for some other standardization, a standard or a proposition on IoT. It defines an architecture, a service, API, structuration of data, and also it had knowledge of data. It's also very active, so it still continues to produce new extension to cover more capability. So it's a very complete standard. We are now on the release 2A will be published very soon, and we still work on release 3. So we had in this new release also some connection to a new possibility in terms of other protocol. There's a lot of work also that continue on security and also in data management. This is the main point of the work. So 3, connect with several other technologies, security and data. Just perhaps some disadvantage. The 1M2M standardization is used to be multi-domain, but sometimes it's not necessary to be multi-domain. If you want to deploy a small application inside your home, you don't need to have interaction with the city, with the government, with other part. So this is perhaps a problem to choose OneM2M when you need to do a simple application, because it's not so simple. If you have a look on other standardization like MQTT or like M2M, a request with MQTT can be only 2 lines of code. It's not the same with OneM2M, even if we will show you some tools that can help you. But the fact is, you don't need perhaps to take all the services inside OneM2M, but you can choose only a subset. So OneM2M is complete, but you can choose a subset. You don't need to use all the things that have been done in OneM2M. The first step to discover this standard could be complex because there's many things. But you have also some documents on OneM2M to explain you very shortly how to develop a first application. So you have some specific documentation that help you to do that and to try to make a less complex development code. So if you need to develop an application of OneM2M, don't take all the OneM2M standardization, take only what you need to do, and this is enough to make an application. Another point, because it could be complex, it means that you have many things to deploy in terms of services, perhaps, on a node. So you will need some processing and memory on the devices. So if you have a microcontroller with a few memory, it could be difficult in terms of energy and also in terms of processing. It's true in embedded system, but in OneM2M we define what we call an application dedicated node, where we can have a very simple code that, for example, do only a request, HTTP request, and do a connection with a gateway with more powerful power. So if you have very light devices, you can also deploy a OneM2M architecture on these devices using this concept of application dedicated node. The other fact is, when we discuss with industry, most companies are very frightened to share their business. With this kind of things, if we want to work with a multi-domain and non-vertical domain, it means that you access to other applications, other data, but also you will share your data. So there is also some work to do to make a new way of business, to imagine the business between companies, and to show how we can pay to have access to other applications, and how we can share also our data in a company. The other fact is OneM2M is a very telco way of see IoT. So to try to centralize all the information in cloud. Most of the companies do that from now. But there is some discussion on evolution to see more fog computing architecture, so to deploy information and to make access to all information also in a node near the user, near the sensor, and not to concentrate on the cloud all the information. It's good for privacy, for latency, so there are some applications that need to do that and to have a more fog computing view, and this is a work also that we have done in research activities. Nevertheless, I think OneM2M is the best candidate for IoT from now. It's the best proposition, I'm sure of this. And when we have done, before to write the OM2M software, we have made a state of art of all what have been done around the world in terms of IoT. We try to be exhaustive. And OM2M is very complete and make a lot of things. It's also easy to participate in OneM2M, so you can get information and documents, but also you can be a partner with a TDAC and become a partner of OneM2M. And also you can contribute to open source, so it's very open. If you have to develop some new functionality, we'll be very happy to help you and integrate in Eclipse Foundation your codes. And already I think there is a lot of opportunity in terms of business and research opportunities. That's what we have done. We have created a software to federate all our activity in the team. So when we develop a new research opportunity with new research results, we try to put inside OM2M and share with the community. Thank you.
And doing my research at the laboratory last CNRS with my colleague Thierry, and we are in the same team.
working on networks and services. So the presentation I will do today, the first one, is about an implementation of the 1M2M standard. This implementation is called Eclipse OM2M. That was initially done by our laboratory, but now, as you see, as you know, it's an open source project, so everyone is welcomed to contribute. The presentation will be like this. So first, just to put things in context, I will talk about what we understand by an IoT architecture or an IoT service platform. Then I will give two overview of Eclipse OM2M. First one is very general, and the second one is going into the technical details and how to use it. Finally, we will do some online demo on how to use the OM2M, Eclipse OM2M project, and do some IoT device manipulation. First of all, an IoT architecture as defined by IoTI, which is an alliance for IoT innovation in Europe. This is the high-level architecture of an IoT system. So we can see it is a layered architecture. So we have three layers. First one is the application layer. This is where you find all the business logic of your domain. Then we have what we call the IoT layer. These are services, usually common to different domains, where you can find enablers for your application. For example, how to store data, to analyze data, manage devices, etc. And finally, the network layer. This is where the layer that is where we can find all the communication and networking, communication protocols and networking technology to connect devices and application. Based on this architecture, we can talk now about an IoT service platform, which is software mainly. That is, which is software linking the devices to the application. So it's sort of an intelligent layer, software layer between the application and the devices. It includes a coherent set of features or common services. Ideally, these services are common to different domain of applications, so you don't have specific services, but the idea is to have one service platform, and upon this service platform, you can build different types of application targeting different sectors. So an IoT service platform is enabler for the communication interoperability, because in the IoT domain, devices are using heterogeneous communication protocol, but also networking technology. So we can see Zigbee, Bluetooth, sometimes protocols that are based on IP, other non-IP, etc. So there is an important heterogeneity in terms of communication. And the role of an IoT service platform is to abstract this heterogeneity to the application. So this is what we call interoperability at the communication level. It means we want to make the application talk to the devices without knowing the underlying communication technology. This is the first step. And the ultimate objective of an IoT service platform is to make these communicating entities understand each other. So not only they can exchange, send and receive messages among them, but they can understand the content of these messages. And this is what we call the data interoperability. So the final objective on IoT service platform is to enable this data interoperability by making automatic understanding of data and also automatic reasoning. I talked a lot about services. What are the examples of services we are talking about? In the IoT field, we can talk about device management services. So you have a huge number of IoT devices deployed in your system, but some features are necessary. So how to provision your device with the right software, with the right application. How to monitor the connectivity. Is it connected, not connected? What is the data usage, the communication usage of your device? Maybe it's costly, so you need to know what is the data usage of this communication. And sometimes you need to, for example, deploy firmware, etc. So these are services related to device management that are very important in the IoT, in an IoT system. Other services are related to messages and data. So, for example, when you are working with IoT devices, you will need a database to store your data. You will need some features, for example, to collect the data, to analyze them, to present them in a specific way, to store histories, if you want to work with time series, etc. And sometimes to design event-driven architecture, you may need something like notification. So you want to be notified about an update on your device or an update on your data, etc. Also, in IoT, you need to handle the problem of access right. Who has the right to access the data, to access the device, to trigger a command on your device? All these things are very important, and you need some service to handle this access right. Finally, an IoT service platform may offer you some services to ease the development of the application. So you may have some SDKs, APIs, utilities to develop, or even environment to do rapid application development. Okay, so an IoT service platform is very important in the IoT because we have a lot of heterogeneity. We want to target different sectors, etc. So you see that here there is a problem how to develop such IoT service platform. So a lot of initiatives have been taken all over the world, and 1M2M is the standard to define this IoT service platform. So 1M2M is very important in the sense that we can develop a lot of IoT platforms and we end up with another problem of heterogeneity. So 1M2M is there to put let's say a frame for working by standardizing what we can find as services in this IoT platform, but also how to access this IoT platform, how to use it. So this is what OM2M is all about. So as you saw earlier, 1M2M is a generic IoT service platform because it's not targeting a specific domain. We can use it to any domain, smart building, smart city, smart agriculture, etc. It's agnostic toward the sector. It has already integrated a lot of standards, so we are not creating something out of the blue, but we are using some well-known standard. For example, in 1M2M, you already have bindings. That means the way you interact with the 1M2M using HTTP, MQTT, CoAP, and even WebSocket. You can also, in 1M2M, you can do device management through lightweight M2M. You can use some standards related to semantics and information representation using SRF or SSN from the W3C, etc. When we look into 1M2M from an interoperability aspect, we can say that there are some features that are very important for interoperability. So to make 1M2M integrated into different systems. I will talk about three features. The first one, which is called the interworking proxy entity. It's something that is well standardized in 1M2M, and that you can develop. It's like translator to any system, protocol, network technology, or even another IoT service platform. So this is the way to integrate something that is non-1M2M compliant. Let's say, for example, you have a fleet of IoT devices that use networking technology, which is proprietary and very efficient for the solution. But you want to integrate all the data reported by these devices through 1M2M for other reasons. The way to do this is to develop an interworking proxy in order to integrate this non-1M2M technology into the platform. Once integrated, your devices can be accessed through 1M2M protocol, which is a standardized way. So another actor that understands 1M2M can access the data and trigger command of your devices by respecting this standard. In the 1M2M consortium, we are working already on interworking proxies to integrate other platforms and systems like OIC, AllJoin, or even 3GPP Release 13. Another feature to enable interoperability is the Flex container. Flex container, before talking about Flex container, you should know that 1M2M give you a frame to exchange data, but there is no assumption on the data itself. So it's up to you to model your data, to format them the way you want, and to put them in this platform. Sometimes when integrating with another IoT platform, we can use some different models, etc. And in 1M2M, we have put a new thing, which is Flex container, in order to enable any modeling of the data container. Finally, the semantic support, which is already in 1M2M, but still in development. So this is what I said earlier, is to enable automatic understanding of the data. So at the end, we want that when the device sends in information, he can point to a description, a semantic description of this data. So any other process or application can understand how to manipulate the data. What is it? What this data represent, etc. automatically. And the 1M2M is the standard 1M2M is implemented. You can find some open source implementation, but also some vendor-specific ones. And today I'm going to talk about one implementation of this standard, which is called Eclipse OM2M. Sorry for the confusion. So OM2M is an open source implementation of the standard 1M2M. This implementation was done by us, by our laboratory, and we decided to sorry?
Question.
Yes?
So the IDE and the containers that you alluded in the previous slide, would they be running on the device that knows nothing about 1M2M?
We can have both cases. Even you have a device that is, let's say, smart enough to talk using 1M2M protocol, or it can talk using a non-1M2M protocol, so it's proprietary or constrained or whatever. And in this case, you need to develop translator to integrate it in 1M2M.
So that's the actual agent running on the device.
Yes, here I'm talking about the code in the device. So
That knows nothing about 1M2M.
yes.
And it takes care of the translation.
Okay. We will see this later. I will explain it in detail. So about Eclipse OM2M, it's well, before being compliant with 1M2M, there was a standard let's call it an ancestor to OneM2M, which is called Smart M2M, developed by into Etsy SDO. It's horizontal service platform based on a RESTful architecture. So you have RESTful APIs to communicate with the software. You have a set of generic services like device management, data management, or, access right management, etc. And we have developed it using Java language and using an OSGI-based architecture. So I will show you in the technical overview of OM2M how it's organized. So you can develop your application independently of the protocol you are using to talk to your device. We'll see it later. The main feature of Eclipse OM2M, you have registration there, application deployment, container management, discovery also, which is a very important feature. You have the access right management as defined by OneM2M, subscription notification to do some event-driven software, group management, non-blocking requests, etc. So a lot of features are there. The project is now hosted by the Eclipse Foundation. It is open source based on an EPL license, Eclipse public license, which is very business friendly. So you can already download the source code, compile it, use it, modify it, enhance it, etc. freely. And we are a member of the Eclipse IoT working group, where you can find a lot of projects related to IoT. So this is a branch of Eclipse targeting IoT project. Sorry. A brief history of this project. So at the beginning, back to April 2015, we were the first implementation of the Smart M2M standard with some features. The first version of OneM2M standard implemented was in June 2016. So we have the release 1 implemented. And we have some features like HTTP and co-op for bindings. For data format, we were using XML and JSON, some security mechanism, and the 3 nodes, as mentioned in the OneM2M standard, which are the infrastructure node, middle node, and application service node. Sorry. After that, we had some enhancement. So version 1.1 give you the MQTT binding and also the Flex container presented earlier. The last version that was published in January this year, we are compliant with OneM2M release 2 in this version, and we have added some extra interworking proxies to communicate using Notion, Hue, lamps, etc. So these are some proxies that you can use to rapidly develop your application. The community around OM2M is very active. So we have a website, om2m.org. It's very active. We are also present, but other contributors too, in the Eclipse forum, where a lot of people are asking some question, and we try to answer this question and make enhancement also to the project. So you are free to participate in the Eclipse project, to ask question, to commit code if you want to. So there is a community that is rising around this project. So you won't be alone if you go for OM2M. Users are all over the world. India is one of the countries where OM2M is famous. For the contributors, we have, well, as I said initially, just a research, our research laboratory, but now we have been joined by some industrial partners like Orange and Dutch Telecom telco operators, but also other universities like NCTU in Taiwan. So this is, let's say, the actors behind OM2M. So we have contributors, but also partners that are that are not contributing to OM2M, but using it in prototyping, teaching materials, etc. Resources. These are the main resources for working with the 1M2M standard. So first, where you can get the open source implementation, om2m.org. If you want to go into the details of 1M2M standard, 1m2m.org, I must say that you don't have to join 1M2M consortium to get the specification. They are freely available, even the draft. So you don't have to wait until the release of the standard. So working documents are already published and freely available for everyone. For Eclipse, if you want to go into the details of the code, you have the Git repository where you can download the code. But also, we're trying to enhance the utilization of OM2M through wiki and tutorials. So when you go to this wiki, you'll find a set of tutorials, how to download, to build, use, and extend OM2M. The basic tutorials are there. So as I said, how to clone, build, how to use a web interface. We will see it, which is a very interesting tool to debug and to develop application. And finally, how to add your plugin. If you want to extend the 1M2M with some, let's say, interworking proxy or an integration toward the specific IoT platform, how to add it is explained there. In a very comprehensive way, step by step, how to compile, how to code, what class you need to develop, interface, etc. For the software organization of OM2M, as I said, it is Java program based on an OSGI framework. So you can see we have plugins that are dedicated to different features. The core plugin is there, where the implementation of the standards happen. And along this plugin, you have what we call binding protocols. Binding protocols are the way to communicate with the software. So when you will download OM2M, there are already 3 binding protocols there. So you can communicate with it through HTTP, CoAP, or MQTT. If you want to add another protocol, there is a way to do it. An interface that was defined, you can implement it and add your new bindings. Content format, XML and JSON are already there, but also you can add your own. We have storage. You can also choose what type of storage you are using for OM2M. So by default, you have H2 database, but you can go for a non-SQL database if you want to, or a time series based database, which is very convenient for IoT application. Then you will find some IPs that are already there for some, let's say, well-known technologies like Zigbee, KNX, Z-Wave, Ocean. And finally, well, there are some plugins also for device management. But finally, you can add any plugins you want. So, for example, you want to do some, let's say, very smart features in OM2M. You can add it as a plugin and use all the rest. If we look into the modules that are making OM2M, we tried to do it in a very flexible way, so you can interchange component easily. You can add component, you can remove, etc. So we have the core plugins that communicate with the rest of the plugins. For example, here you have all the binding protocol that the core can use, and the core has been designed in order to discover what there is deployed in the software. And you can remove this binding even in runtime. Plug them and remove them in runtime. Also, the same for IPE. You can the core discover them, and it's very dynamic. And finally, the database and the storage too. For example, if 1M2M receives a request through HTTP, this is a path that will be followed by the request. So first of all, the HTTP binding will receive this request, and then it will remove all the information related to HTTP and gives an independent, a protocol independent data object to the core. This is very important in 1M2M because 1M2M is protocol agnostic. Doesn't know what, doesn't have to know what protocol we are using to talk with this node. So all what the core will see are requests in a generic format and answers with the response in a generic format. So it's up to the bindings to do the translations. So doing so, we can receive a request through HTTP, but we can respond if we want to, and if it is possible, through another protocol, because the bindings will be there to do these translations. Okay. So now we are going to talk and to see the REST API in action. Usually, when we consider an IoT solution, we have this picture in mind. So some devices in a localized area, and in order to integrate them, we put the gateway. This gateway is most often connected to another server in the cloud through an IP technology, for example, 3G connection. But in the context of the IoT gateway, the devices usually are connected through specific technology. So we can have Bluetooth in home, Bluetooth devices. The gateway is communicating to a server in the cloud through your DSL connection, etc. And finally, you have an application that wants to use the data to visualize it, to analyze it, or to trigger commands, etc. So this is a typical, let's say, architecture for IoT. But you're not obliged to do this with 1M2M. So for the demo, I'm going to consider, a simpler context. So we are at home. We have some devices, and we want to develop some application to talk to these devices. So here, no need to have two-tier architecture. So we will have just the gateway that communicate with the devices, and I will talk to the gateway to develop the application. But keep in mind that this is also possible. So you don't, let's say, the small number of nodes that let you try 1M2M and develop application is 1. So this is what we will see. If we look into the functional overview of this solution, we have the gateway that will host a program, our Java program, which is called CSE. We can talk about two types of CSE. So if it is, let's say, like this into the gateway, we can talk about a middle node CSE. And the server will be an infrastructure CSE. But generally, it's a CSE. In the vocabulary of 1M2M, CSE means common service entity. This is the software where you have the set of your common services. So this CSE will host application entities. These application entities are the representation of your environment. So let's say every device will be represented by an application entity. But also we can represent software application too. So all the application entity will be hosted under this CSE. Okay. we will see it in action, but just to represent it again, this is a data representation of the IoT system at the gateway level. So the gateway will look into the system as this. So different application entity. Let's have in mind that an application entity can correspond to a device, an IoT device. How to describe this device? You can put a lot of things there. Usually, we do we store there two types of information. So we create a container where we put data about the generic description of the device, and another container where we store all the data values of this device. So we will have two containers, and in every container we put data items, what we call content instances in 1M2M. And we will see the subscription notification later. So I'm going to replay the scenario presented earlier, but this time with an emulation of the smart meter. So this is the setup. First, when we run the CSE, so the program that is running on this gateway, we will have the resource tree as this. So it's empty. The tree is empty. So we will launch it. Sorry. So when you download OM2M software and you build it, you can launch this software. So you will have something like this. Here I am launching. I am preparing two CSE nodes, but I am going to use only one. Inside, when you build, I don't know if you are. You can see. Okay, so this is a Java program. When you build it, you will have the software that is prepared for you in this folder. You can find some scripts are already deployed for you in order to launch the software. But also, if you want to configure this software, you can also have access to this file and edit some properties. But what you download, if you compile it, the default configuration can fit most of our users. So you don't have to go there and change the settings. Okay, so I will launch the software. So I prepared a shortcut for me. So this is what you get. A console program where you can see some information about debug information. Okay, so the software is running. CSE started. As an OSGI program, you can see what are the bundles and plugins that are deployed. So here you have the list of all the Java plugins that are embedded in this software. So you have some bundles related to how to do HTTP, co-op, etc. Also, these are the OM2M plugins. So we have co-op binding there, HTTP, MQTT, some interconnecting proxy is there, and the web interface. So we can talk to this software by two means. First one is the REST API, and the second one we have prepared a web, let's say web app, where you can browse the resource tree. So as an OSGI application, you can start, stop services, you can add at runtime services, etc. Okay, so the software is running, and I will try to connect to. So by default, the software is listening on port 8080, and I will look at it. A simple authentication form. The default one is admin, sorry, and we are going to use it. So here, what we can see is the resource tree that is maintained by this CSE. So for now, it's empty. We have the root of the tree, which is the CSE, and we have already one resource. I will explain it this afternoon. Related to what are the rights this user has in order to discover the resources, create them, update them, etc. We have some at the right the generic information about this, the attribute of the resource. Sorry, so we can see here this information is 1M, 2M vocabulary, and represented in short format. You have the long format too. So TY is for type of resource. You will see in the standard that 5 corresponds to a CSE base. You have some information about creation time, update time, etc. So these information are in the standard if you want to read them. Okay, so this corresponds to what we have here. Donc, as the CSE started, so the resource tree is empty. What we will do is create a representation of our device. Let's assume that we have a device, okay, that is connected, and we want to create a representation for it. So what we will do is, through the REST API, we will do these calls. So the first one, what we call the registration of an application entity, it corresponds to the creation of this resource. So it will be a post in HTTP. I'm going to use HTTP. I will target it to the CSE. The CSE is listening on port 8080 on my machine. I will use a header, an HTTP header, to say that I'm the admin who is requesting this call, and the application format, the content type I am submitting in my HTTP request is in XML and corresponds to an application entity as defined by 1M, 2M standard. I will give the representation in XML of my resource, so it's in AE, application entity. I'm saying that this this AE will be named AE LUM sensor. I'm free to choose what name I want, and I'm giving some labels to this entity, like the type is sensor, the category is luminosity, and the location is home. So I'm free to set whatever labels I want for this application entity. Okay, so the expected result is in HTTP 2001 for created resource. I have prepared some request in HTTP using a REST client, which is called Postman. So it's a very convenient tool to use REST APIs through HTTP. So I will load the request I already prepared. So the request I'm looking for is the creation of an application entity. So you can see that is targeted to the CSE on my machine. The headers, the originator of the request, which is admin, and as I say, the content type, which is in XML and type 2. In the body, I am putting the XML representation of the application entity. And I will send it to the CSE. I got an answer. The answer, if we look to the code, to the status code, is 2001, so the resource has been created. And OM2M will always, when you create a resource, will always respond with the representation of the resource it just created. So we can see that there are other information I didn't supply, but are there now. For example, the creation time, the last update time, the parent, the resource unique identifier in the system, etc. Okay, let's see what happened on the web interface. So now if I update, we can see that we have the resource created here under the CSE, application entity lumen sensor. The attribute I get from the response. So all the information are there. So with one call, I created the application entity under the CSE. Now I can retrieve it also through CRUD operations. So when we talk about REST API, we are talking about 4 methods, 4 operations. This is what makes a RESTful API very easy to use, because we see everything as a resource, and we have only 4 operations to do. So we can create the resource, retrieve its information, update it, or delete it. So everything can be modeled using these 4 operations. So if I want to do, and these 4 operations are mapped over HTTP protocol. So the post is related to the create operation. If I want to retrieve the state of this resource, I will do a get method in HTTP targeted to the CSE. Here I will have the information related to the CSE. So I'm saying that I am the admin, and I will accept data in XML format. Here, as I requested information about the CSE, I will get the representation of the CSE. So type 5, creation time, last update time, etc. What are the resources that are supported, etc. I can do the same to access my application entity I have created. So here I will have a representation of the application entity type 2 and other information, labels also. By default, 1M2M supports XML and JSON, and you can switch between them as you want. So for example, if you develop an application but you don't have libraries to manipulate XML, but you have JSON, typical case on a web application, you can specify it here, and OM2M will adapt and respond you in the format you want. So here, this is the same representation, but in a different format, in JSON format. Okay, so back to the slide. So we created this application entity. Okay, now the application entity, well, is just, let's say, a node, but we want to do some organization inside this, under this node, sorry. So we will continue with the calls, but now we want to create a container where we will stock the description of the device. So also you need to do a post call. Yes?
Is there a user interface to register the or just a REST API?
For now, we don't provide this kind of interface, but you can do it through the APIs, like I'm doing now. But this kind, yes, this part should be handled in a more efficient way in targeting your solution, how you want to register devices, users, etc. So it's something that you will need to do in order to have a production-ready solution.
The schema of the data elements that we need during the registration, is that are we free to enter any kind of information there, or is that restricted?
Yes, you need to respect the 1M2M standard. So for example, in this call, I needed to follow the 1M2M standard. So what we mean by 1M2M standard is that I will use this data type called AE defined in some XSDs that is available on 1M2 website, and there are some attributes that I need to supply. This part is where 1M2M happens. So you need to be compliant with the standard. But what you put on your the data, we will see it, you are free to do whatever you want. So for example, in the second call, I'm going to create first a container where I will stock the description. So it's the same thing. We have a post call. This time, the URI is the application. So the container I'm going to create will be under the application entity. The type is 3 for containers. And the representation is very simple. So there is an XML element defined for that, so CNT. And I will need to supply the name of this container. Here, resource name is a descriptor. And I will expect created message. I will do the same for the other container. If you remember, we have 2 containers. But this time, it will be for the data container. So to the same, under the application entity, type 3, and the name is data. So let's do this. So I have the request prepared here. So the URI is targeting the application entity. The headers, I am the originator admin, and the content type is type 3 in XML. The body, as you saw, this one. But I need to supply the resource name here, descriptor. Okay. So the container has been created, and I receive a representation of this container. I will do the same for the data. Created. So here, if I look into the web interface now, under the application entity, I have 2 elements, descriptor and data. The third step is to populate these containers by giving some data in both containers. So under the descriptor container, I will put a generic description of the device, and under the data, I will put new values transmitted by the device. Okay. So after that, we have this kind of tree under the CSE, and I will do the content instances. Sorry. So back to Postman. Okay. Here I have a generic description of the device. So you can see that the request is targeting the container this time, but not the application entity. The headers are the same, except the type is 4 because it's content instance. And for the body, okay, this is very important. So here I am submitting data to be stored in the software. So I'm doing 1M2M protocol, so I need to respect it. So you need to express it using a specific XML element. The content format is application XML, and I'm supplying XML. So I decided for this demo to use data represented in XML format, but I could use any other format. I could use a text or whatever I want. So what I need to put between these 2 elements, content for con, it's up to me. It's not part of the standard. The envelope is part of the standard. You need to do it like this. But what you put in here, it's up to you. So here I choose to do it in XML format because it's convenient for me. But when you do XML in XML, you need to record the XML in a format that doesn't make problems with the parent XML. So this is just a representation of an XML document. So I will create this thing. Okay, so this content instance has been created. Let's have a more human readable form. So This is what I submitted in recorded in different format. So it's in XML, but using an OBIX model. OBIX is a data model that was standardized to describe devices in a building or a home. It's for home automation. And it's very simple. So you define object and data element inside. And the XML element is corresponds to the data type. So here I'm saying that my data is an object composed of 3 strings. The first one is the type, and its value is luminosity sensor. Location and its value home, and the app ID is application entity lim sensor. Here I provided also a 4th information, but this is just for the web interface. Okay, so if now I go to my application entity, I can see that there is a new content instance under the descriptor. And if I want to browse it, I have the generic attribute here, but my content data is here. When you will use OM2M, you need to know that, as I said, the content is up to you, the format. But if you use OBIX, as I did, you will get let's say, convenient way to see this to see this data. So here, because it is in OBIX, I have this table with the different attribute, type, luminosity, location, home, etc. And you can describe also operation that if you want to have them on the web interface. So here I described a new operation on how to get the data from this device. I can click it, but there is no data yet under this container. So here, to get the value, I'm just pointing to, to the last content instance of the container data, which does not exist yet. Let's do it. So let's populate the container data with some values. So I will do the same. Okay. Okay, the body the same. So I'm providing a data modeled in OBIX. So you can see that it's small envelope. I'm saying that the application ID is the application entity lim sensor. The category is luminosity. The data is 2, 3, 4, and the unit is lux. But you can put whatever you want there. So let's send this data. Okay. Let's send a new data, another one. Okay. So now under my resource tree, I will find always one content instance for the descriptor, but now 2 content instances under the data container. The first one is 2, 3, 4, and the second one is 4, 5, 6. When you interact with containers, you already have 2 specific URIs, one to access the oldest content instance and one to access the latest one. So let's use them to get this data. So for example here, I am looking for the latest content instance under data. I'm saying that I accept XML, and now I will do this request. It's simple get. So I get the information, and the latest was 4, 5, 6. If I want to get the oldest, I get the oldest. So this can be very convenient to access. For example, if you have a device that is updating his state, you want to get access to the last one only. Okay, so here, what we did, so we created the representation of our emulated device. We described it this way, and we set up a place where to put the data. So let's assume that these two content instances have been submitted by the device. But in order to do things like this, the device needs to do to send this request. So request in HTTP format. So all what we did here. So if your device is not able, so this is what we can call an application dedicated node. So the device is able to form one M2M request, but sometimes it's not the case. So maybe your device is too constrained to run an HTTP stack. So you will have just let's say non-IP technology where you send only the data. So here, for example, you saw that for this interesting value, I sent a lot of data. We had an experiment where we wanted to do something like this in our laboratory, but on small devices running 6LoWPAN. 6LoWPAN is IPv6 over constrained technology. But we noticed that the size of the payload was like 46 bytes. We cannot put this in 46 bytes. So just for one message, the message gets fragmented into a lot of packets, etc. So it's not always appropriate to use 1M2M. It depends on the case. But 1M2M has already planned for this scenario. So if you have a constrained device, let's say with a very constrained communication, etc., you can keep the device like this because it's optimized for your setup and develop what I presented earlier, an interworking proxy. So an interworking proxy, it's a piece of software that you will add to OM2M, will receive your data from the device in this optimized way and translate it to 1M2M format, and you can access it through internet or through my web interface. So this is why interworking proxy are very important to integrate legacy and specific technologies.
The data is hard-coded, right? Whatever the data you hard-coded.
I am putting the data there.
Yeah. In general scenario, suppose some sensor is giving the data, some I2C interface or any other interface. The data comes, so we need to provide the data in some kind of packet format and send it via some network socket call to this guy. Means how to integrate that data packets like here, dynamic data.
Okay, yes. Let's assume that we have a temperature sensor connected in I2C to your microcontrollers. You need to have some software to read this data in an I2C interface. This is up to you. It's not 1M2M yet. Then you want to submit this data to a remote location. The remote location is what I showed here, the gateway. The gateway, it's PC, it can be whatever you want, Raspberry Pi if you want. So you need to consider what is the communication that is between your microcontroller and this gateway. And we have two cases here. No? Yes? We have two scenarios. Even your microcontroller is powerful enough. Okay, we skip this one. We skip this one. Well, the idea is that if your microcontroller is powerful enough and you have an IP technology to this gateway, you can form this kind of messages, and you can use on the gateway the default version of 1M2M, and your device is integrated. So the effort will be just in forming this request at the microcontroller and send them through HTTP or CoAP. CoAP is also constrained, so you can use it for this kind of scenario. The second option, suppose that your microcontroller does not have IP, is using specific radio technology, let's say in the band of 800 something like megahertz, something like this. So here you need to do some effort at the gateway. So you cannot change the microcontroller part. So what you will need to do at the gateway is to develop a sort of translator. So you will have a piece of software near the gateway to receive your data in the radio technology, etc. And after that, this piece of software will populate the resource tree I have shown. And this piece of software is called IPE, Interworking Proxy Entity. It is well standardized in 1M2M standard. You can see what there is there. And if you want to develop one using OM2M, there is a tutorial on the website. What is the code you need to write, etc. In Java, so you need to manage the thing with your IDU. It may be tricky, but you can still do it.
This data like this we can give in the JSON format also.
The device?
JSON format or JSON.
Yes. So yes, the same. As I show you, I can get the response in XML or JSON. As I can specify it in the header, so I can say, and even here I am using representation in XML. All what I've submitted was in XML, but I can use also JSON format. So it's already implemented and supported by 1M2M. So these are the two ways to integrate legacy or any system. Even if, always two options. And you need to ask yourself the question, do I need to develop a translator or not? It's up to you. Okay? So back to the demo we have. So we created all the resources. We have something like this. Now we have one description under the descriptor and two data element under the data container. Okay, now let's assume that there is a device, a powerful device or a software application running on my PC that is interested in having notification about new data. So now, to access the latest data, I need to do a GET. This is synchronous way to access data, but it's not very efficient in some scenario. So what I want to do is to get notified about new data. So I don't have to do the polling, and I want to be interrupted whether there is a new. So there is a mechanism that is defined in 1M2M, which is called subscription notification. So we will make the device subscribe to a new update of the data. To do this, I need to create a resource, which is called subscription resource. Depending on what URI I am using here, I will get the update of this resource. So here, how to interpret this URI is that I will create the subscription resource under the data container. It means any modification on the data container will trigger notifications. I could put the subscription under the application entity, and here, any update on the application entity will trigger notification. So here I am narrowing the type of information I want to be notified about. The type is defined in 1M2M as 23. So here I am saying that I am creating a subscription called sub-AE lim sensor under the data container. And here I have two important information. The first one is the notification URI. When there will be an update, how I want to be contacted. So here, let's assume that our software application or our mobile application will receive notification on this port using HTTP and under this context. Another important information is what type of notification I want to have. In 1M2M, we have defined 3 or 4 types. This one, when you set it to 1, it means that if there is an update, you will receive a notification, but including the data, the new data. Another way to interact with the subscription is that maybe, for some reasons, you want to be notified about the existence of the new data, but not the data itself. Let's assume that the data is very huge in terms of size. So you just want to know there is a new data. It's up to you to request it later. So you won't have it inside the notification. Here I choose to put 1 in order to have the data inside the notification. So let's submit this this request. Okay. Before subscribing to this update, I need to be sure that I am able to receive notification. So when you go to the Eclipse 1M2M project, you will have a piece of software, very simple, an HTTP server that you can run in order to receive notification. This is what I am going to use. So I will run my monitor. It said it's small application. The server is now listening on port 1400 under the context monitor. So let's create this subscription. Okay, so the resource has been created, and let's see what happens on the monitor already. At the first time I'm subscribing to update, here 1M2M has taken precaution before accepting my subscription. 1M2M has tried to contact this monitor. Is it still there? Is it reachable before accepting such subscription? So I have received what we call a verification message. So 1M2M has verified if I am reachable or not. So it's there. In the resource tree, we will find something like this. So data, we have the 2 content instances, but also the subscription. Let's assume now the device will send new data. So he produced new data. Okay, I will submit it. Created. And if we look into our monitor, the monitor has received a notification, but containing the data element transmitted by the device. So what happened here is something like this. So we created the subscription. As the new value arrives to the gateway, this has triggered a notification, and the notification was sent to the device in an asynchronous way. So the notification is a resource that is described in 1M2M standard. So you have the different attribute, and what we received, what is important for us, is that this attribute content containing the information sent by the device. So here, if I want to look into, I see that the data sent was 999. So it was the last value transmitted by the device. As we saw here, it was this value as I sent. So by this feature, you can develop efficient application, because you don't have to do the polling and do periodic check, etc. So you can organize your application to receive notification about any update in the system. So you can, for example, want to be notified of new devices that have been discovered in the system, new description, new data. You can specify an update of every resource in the system, and everything is a resource in the system. So it's very fine-grained and very convenient to do a lot of stuff. It can be compared to MQTT, yes, because we can say that the update I am looking into is the topic of MQTT. And if there is an update on this resource, I will publish on the same topic. We can compare it to MQTT, but it's not MQTT.
Like, for example, what I mean is, in MQTT we can get with a star, I can get all blocks and something like that.
Yes, here, if you want to do something like this, you need to go upper in the tree. For example, if you put your subscription under the CSE, you will receive notification about all the update of the CSE, of the resource under the CSE. So it's comparable to the star wildcard in MQTT. Exactly, yes. The way to communicate with OM2M in request or in response can be XML and JSON by default, but you can extend it easily to other format. I guess another format is CBOR. Yes, CBOR, which is very convenient for a constrained device. CBOR is a work done in ITF. It's in the same working group as CoAP protocol. And what is convenient is that you can, for any reason, I don't know, you can send a request in JSON, receive the response in XML or whatever you want. So it's very interchangeable. So okay, so this ends my first presentation. So if you have any question, feel free to ask. Here, what I show you. I have used a REST client that is very famous among the web development community. It's Postman. But you can do the same using Java. Doing REST calls is very easy in almost every language. So you can do this request very easily. Here, for example, I'm showing just a small application. Okay, so in this application, it's a Java one. I am using a REST client. The application, very simple, is in a loop. Try to do polling to access the last data of a certain application. So I specify the URI I am targeting. Okay, for example, here I'm targeting the latest data item of the device named Mylium Sensor 2, which is not present now in my CSE. The headers, the originators, and what format I am accepting. I execute the request. I'm doing a get. If it is OK, for example, in Java, you have already some libraries to manipulate JSON. So here I'm choosing to receive JSON object. So I can do the unmarshalling very easy. So we have the library, and I will get the object directly here, and I'm printing it. I'm printing just the con element of it, not all the envelope. So here, as you saw in the notification, when you receive something from related to data, you will have an envelope, and there you will have an element which is called CON for content, and it's there where you find your interesting data. So here, my application is printing this data, and I'm doing this in a loop. I can write the same program with the same number of lines to, for example, to trigger commands through a post calls. So you can see that it's very easy to interact with OneM2M because it's RESTful. It's over something that we all know, HTTP. So if your language, programming language, lets you program REST client very easily, you can access all the devices, all the sensor and actuator, whatever technology they are using. This is the let's say, the added value of an IoT service platform like OneM2M.
Let's say my devices are like some storage devices.
Sorry?
Storage.
Storage, yes.
Okay. So it's not like a sensor based to give the dynamic data. So in that scenario, let's say I have target. My targets and few of storage devices are there.
Mm-hmm.
Okay, I am the server. I have the map to all those storage server to my current server. Okay. So let's say some of the one machine, it wants to track what all the devices are available.
Mm-hmm.
Okay, so that's the static side. So once you got the storage device, it won't change like sensor data.
Exactly.
So in this kind of scenario, would you suggest to use the REST APIs?
Yes. You can use it, yes. There is no, I don't see any convenient to use it.
No, because it's just a static data, right? So for this, is it necessary to use REST APIs?
It's up to you. if you, as I discussed earlier with someone in this room, why do you need 1M2M? You need to ask yourself this question. Well, I can give you two options, but other option exists. First one, you need to handle heterogeneity in your solution. Suppose that you have a lot of systems, okay? Let's say a lamp that is connected through Zigbee, but the switch is in Bluetooth. Okay, I want to write an application to connect these two objects. When I press the switch, the lamp will be connected. So there is problem of heterogeneity. If there is no 1M2M, I will need to develop an application that use Bluetooth. I will need to be an expert in Bluetooth and expert in Zigbee, etc. If I add another technology, I had to be an expert in this. I have to be an expert in this technology. So the problem of heterogeneity is there. 1M2M can be the solution to this, because, well, there are some technologies that are very common in the world. So we have already interworking proxy for them, like Zigbee, Bluetooth, etc. So I can take 1M2M. 1M2M will abstract the networking technology for me and expose this kind of IPA for me. So I can access the state of the switch and trigger command on the lamp. 2 lines of code. So this is one option of using 1M2M to handle interoperability. Second option is that you don't have this problem of heterogeneity in your system. You have the devices all using, let's say, I don't know, Zigbee. You have in your room all devices on Zigbee. And you are an expert in Zigbee. So you already have your solution working and working very good. But maybe for some scenario, you need to expose this data, this command to another actor. For example, let's say the building management service of your university. They don't have to be expert in Zigbee to switch off the lights at the end of the day. So 1M2M will be an option. So you keep your solution in Zigbee, but you do some, let's say, information exposure in 1M2M, and you say, I'm exposing 1M2M. It's standard. So if the service, the management service, understand the 1M2M standard, it will communicate with my system easily without any documentation I need to supply, etc. Because it is a standard way. This is the power of a standard. So it's a way to interwork with other in a well-defined frame. So these are 2 options I can state for 1M2M, but others exist. So if you don't have any question in this about this part,
most of the devices may not support Java.
yeah.
I mean, if you say that my gateway is itself a constrained device.
Okay. OM2M is written in Java, but I don't have to write my client in Java. I use it through Postman. Postman is written on JavaScript. So if you can do HTTP calls in your language, whatever language it is, you can interact with 1M2M. We have some, for example, for teaching, we have some clients written in Arduino code, so in C. No, because it's up to you. You are the expert.
I'm just getting the sensor. If I use the REST packages, I'm just getting the sensor values of any other. If I want to actuate something, I can actuate it. But in order to get the entire tree hierarchy or whatever it is, I should have at least some very lightweight package from OM2M.
If this is the option 1. No, option 2, sorry, I talked about. So if in your system you need to have this optimized communication, you don't have to use 1M2M because 1M2M has an overhead for you. But you can put in some effort on the gateway to do the translation for you. So keep it optimized in this segment between the device and the gateway, and 1M2M will take it from the gateway to the internet. So it's very specific to your scenario, how to deploy 1M2M, in which segment and for what reason. So what is the reason? This is the first question. What is your objective on using 1M2M, and considering your solution, where does it make sense to have it? Yes. So,
See, I think before that we talked about the sensors. And what is the sensor is bit simple when comparing the transducer, the actuators where the feedback loops are needed. So how MPM is going to help in maintaining the state machines of the actuators. For example, we want to increase certain speed of the machine and then again get the feedback. These are purely RESTful things. I think probably in this context.
yes, it's the question you ask is that can we do control command using an API based on RESTful API? Short answer, no.
No, I'm not talking about the RESTful APIs. But when you have the MPM in between, the client is RESTful API, it's okay. But when the MPM to transducer, that is the actuator or transducer, if it is an actuator, then you're trying to do some sort of control, then the state machines between the MPM and the actuator is most important. And then again coming to the client part. No, I'm not talking about the client part. That's okay. I understand from the REST point of view. How MPM is maintaining that state from the MPM core,
Yes.
like the CSC2,
The gate.
to actuators.
There is no guarantee to do that. We can, for example, there is the time stamping of the data, but Laurent can correct me if I'm wrong, but I think there is no specific thing to handle this in 1M2M.
Okay, that's the first question. And the second is, let us say, for example, most of the time we need the calibration of the sensor. If it is an industrial grade or something, it's not just simply taking the data. For example, you have to make sure that the units are, engineering units are pretty clean, or maybe the tolerances or thresholds are maintained. Then how to maintain that the calibration units in the MPM to the sensor itself, not an actuator. Actuator is much complex problem, but even the sensor itself needs that information to be calculated. How MPM is going to address that?
It's not the job of 1M2M. The short answer is this. The question is very important. Why do I need to use 1M2M? And for what objective?
Let's say that this is a simple industrial application where the flow control is important.
Mm-hmm.
And in the flow control, the flow sensors, the transducers, the K factor as the calibration factor. And based on the type of the liquid, viscosity or something like that, I have to set the calibration factor. And to set the calibration factor, the interface with an M2M, whatever the gateway level, to the
Device.
The sensor or the transducer where the flow control, the flow meter is located. This is a private communication. So I have to tell only to the MPM, and MPM should communicate to the flow meter. So how this MPM is going to help the such situations involving where the calibrations are needed?
It won't. You can do it with device management if you want so, but it's not the role of 1M2M to help you doing this. 1M2M is to expose information about devices, or to receive a command that you want to trigger on a device, something like this. But it's not a data broker. This is a lot of people think of 1M2M as a data broker, as something to communicate with the device. But it's one of the features, but it's not the most important of 1M2M. So
Only from cloud to gateway and gateway to
you can deploy some code in compliant with 1M2M on the sensor.
But then if it is not talking to the
If it's not capable of writing 1M2M PA, yes, it's between the gateway and the server. A tool that we have developed in our laboratory that enable you to rapidly prototype an application, an IoT application. So my presentation will be about the use case we are considering for this demo, but also for the hackathon and the material provided for you in the virtual machine. We will first see how to adopt a user, an end user perspective and try to develop application, and then if we have enough time to see how to extend OM2M to integrate a new technology, for example. So if you download the virtual machine that is provided with this tutorial, you will find a topology of 1M2M nodes, 5 nodes. We have one infrastructure node, which is the IN node or the INCSE, and then 4 gateways connected to this IN server. So these 4 nodes are one that represent a home building, the other one is representing an office building, third one is for the bus, and the fourth, the last one, for what's happening in the street, devices that are deployed across the city. This emulated deployment is based on a mock-up that the student will be using in the hackathon that correspond to this figure. We have a lot of devices under each gateway. For example, on the bus, we have some sensor outside the bus, for example, measuring dust, gas, movement, sound, etc. And also sensor inside the bus. For example, we have 2, one for measuring the temperature and one for receiving the push, the user push on a button. And also we have an actuator inside the bus, which is an LCD display. So we have a lot of resources like this deployed all around the city. And the idea is to let students imagine a scenario where they can mix different data from different sensors and act on different actuators, etc. So it's up to them to imagine one application. Okay. Well, the applications are, you can imagine a lot of them. So you can do smart energy based on the presence of users and to what actuator you need to activate, for example, the fan, the light, etc. Street light management, smart parking, etc. Okay, so if we want to develop this kind of application, we have chosen 1M2M because, as explained earlier, it's a standard that lets you develop application without knowing what is the underlying technology, etc. So it's a good choice for start. We can interact with the devices seamlessly, independently from their communication network or data format. 1M2M exposes a RESTful API that is very easy to use for operation, and we can do whatever we want. We have some well-known protocols we are using since years, HTTP, and you can write a REST client almost in every language. So it's easy to do that. But the developer still concerned with some aspect before starting his application. He needs to know what are the devices he wants to communicate with, the names, etc. But also what are the format and how to get the value from this format, etc. So 1M2M has simplified a lot of things, but there is something left the developer needs to do something before start writing his application. So what we tried to do in our laboratory, we tried to enhance the utilization of OM2M through the provisioning of friendly tools. So we developed what we call an IDE, an integrated development environment, based on Node-RED. So Node-RED is a framework that has been developed by IBM, and now it's an open source, is used to, in a drag and drop format, graphical interface, is used to connect and use online services like social media, access resources on the web, etc. So we will use this for our tool. So we will have web-based IDE, multi-platform, drag and drop features, and you don't have any knowledge about 1M2M to start using this tool. Along this tool, we have a kind of dashboard that represents the system and emulate the system that we will be providing in the virtual machine tool. It's more a user-oriented view, so you don't have the debug view that we saw earlier with the web interface, where you have a lot of resources with some specific name, technical vocabulary related to 1M2M, etc. So here we're focusing on the user and how to develop an application. And since it is emulated with this tool, you don't have all the troubles related to hardware, configuring the hardware, connecting it to the right voltage, etc. So all these troubles are avoided. To develop our tool, we started looking into an IoT system from a different view. So it's a very high-level view. First, we can distinguish two types of IoT devices. Every device can be seen as a sensor providing data or an actuator exposing command. We added another entity to this view, which is the OM2M entity. It means what is the server I'm connecting to access the sensor or my actuator. It's a sort of point of contact. So my system is three entities. A point of contact that I am communicating with to get access to the device, and all the devices can be seen sensors or actuators. Of course, we added some utilities to these three entities. So we have let's say, tool that let you look into data, a complex envelope of data, and look to a specific value. For example, you saw earlier that when I request data, I get a whole XML message where the data is just a number inside this response. So in order to have direct access to this data, we developed what we call a data extractor to give you this data. And some nodes to do some flow control, application flow control, like specify condition and also receive notification from OM2. I talk about sensors and actuators, but when we need to identify one of these, a sensor or actuator, we have defined three ways to do it. Even you know the name of your device, and you can specify it by its name. So this is what we call, for example, named sensor. I want to access room temperature sensor located under gateway 1. Sometimes you don't have the name of the device, but you have labels. You can express labels in order to identify this sensor. So we have labeled sensor, also labeled actuator, and then you can express things like this. I want to access a device with the following labels. The location is room A, the type is temperature. And finally, this is an advanced way to identify a device is by using semantic query. So using Spark language, you express the identification of your device through a formal query. that can be interpreted like this. Device of type sensor measuring temperature located in room A. So it's, but you need to do it in a formal way using Sparkle language. So you have 3 ways to identify either a sensor or an actuator. We will see some examples. First, the first one is how to retrieve a value from a named sensor. It means a sensor which name is known. So we'll see this in action. First of all, I will show you how to run this. In order to run this, even in Linux or Windows, you need to start by launching Node-RED. Node-RED is a command line interface. So all what you need to do is, I won't do it, but I will show you. Start Node.js command prompt and type Node-RED in order to launch it. So this is what I did, and I have this this debugging window. Okay, so Node-RED is run. It's independent from 1M to M. Now I will launch, the scenario, the smart city scenario. I have, as explained earlier, 5 CSE. I will launch them here. So I start with the IN. The bus, the home building, the office building, and the street. Okay, so let's connect to the IN CSE. Okay, so these are the 4 gateways that are known now by the CSE, by the server. So we have the gateway located in the office building, the one in the street, the one inside the bus, and the one in the home building. In 1M2M, you can browse, discover what is happening in your system by having just one contact point. So here, I am still connected to my server, but I will look into what there is inside every gateway. For example, let's go into the bus. I have a link like web browsing. So here I am exploring and I'm browsing what is inside the bus, but still connected to my server. So what is happening here is that the request is being redirected directly to the bus. So if I may draw the topology. Okay, so we have a start topology where the server is located in the center and the 4 gateways here. The user application, my browser, is here and communicating with the IN. So the first listing I had, it was the listing of the IN. Now I am sending requests that do this kind of stuff through the IN, and I am looking at the resource tree of one of the gateways. This is very important because sometimes the gateway is not reachable from the outside. For example, if an operator is running such a platform, let's say that the middle node, the gateway, is located inside the home of the user. You cannot access it directly. The provider can let you have access to the central entity through which you can access your gateway. So the gateway is not reachable directly. So this is what is happening here. So we can see all the devices that are there, for example, the sensor and the actuators. Since everything is linked, this gateway knows the existence of the IN, and I can go back to the IN and go to other gateways. Okay, so here all the resources are there. Let's focus on, on the home. Node-RED, when you launch Node-RED, you will have this kind of stuff. So Node-RED is an application written in Node.js. So it has its own web server. I'm connecting to it, and is listening under the port 1880. Node-RED works in flows. So an application is what we call in the Node-RED vocabulary a flow. Okay, let's start one flow. You had a lot of modules that are here by default from Node-RED. And what we did is to develop a small contribution here to communicate with OM2M. So first of all, as I said, I need to specify the contact point for my application. What is the contact point for my application? I need to define this information. So I will give it a name, for example, home. And this is the label that will be shown. For the home, I need to contact my IN CSE, listening on port 8080, but I'm not going to the IN directly. I will go to the home building. Okay, I give the credentials to access this resource. Okay. So the contact point is set. It has a name, home. Let's identify device by its name. So I will drop named sensor. I will configure it here. Say that what entity I'm going to use to get access to this device. Let's say home, the only entity I set up earlier. The sensor name. So if I remember the list of resources we have under the home, let's access the temperature sensor outside the home. So out sensor temperature. Okay, what container I'm interested in? It's the data. The content instance, latest, oldest. Let's go for the latest. And I will give it a name, temp sensor. Okay, so my sensor is identified. Now I need to show the value I will receive from this, all the data provided by this sensor. Node-RED provide the way to visualize anything in the system. It's called the debug node. So I will just connect the two. So the data that is provided by this sensor will be shown into the screen here in the right. Okay, I need something to launch this application, if we can call it an application. So Node-RED gives you some module to do that. It's called, sorry for the input. The use of the magnifier is, I will copy it from another flow. Okay. So this is the specific node designed by Node-RED. It's like a button to trigger the start of your application. So I will connect it to my device. And I will launch the flow. So here I have a flow, composed of a named sensor, and I want to show the result of this query. So I will start by deploying this flow. And, okay, it's already started. Here we have the result of this query. You can see that is still the XML envelope or the JSON envelope here that is embedding the interesting value. So this is why the utility extractor is useful. So I will go for it here. And instead of connecting the device directly to the output, I will pass it through an extractor process and then show the result. And in the extractor, I'm looking into the data value. You have pre-configured attributes that are most common in our deployment, like state, data, or you can specify query in order to look into the exact element of your XML or the JSON if you are using JSON or XML. So it's like XPath or GPath. So you can specify the path to your value inside the content instance. So here, for me, it's fine because I know there is data. So I will look for data, and here, okay, a name. And now, let's see what happens. So if I run this one, I get directly the value here without all the envelopes. So the output is just 5. Okay, so this is an output from another flow, but the output of my flow is just 5. Okay, so here I, in just drag and drop 4 element, I created what I did earlier by my get API to retrieve the value of the device. So this is a way of using Node-RED. Let's suppose we don't know the name of the sensor. So I want to be using this device. So I just keep it here for demo. And now I need to specify the device using labels. So I'm using labeled sensor. Okay. Again, I need to connect it to the trigger and then extract the value and show it on the debug console. Here, same thing. I need to specify the OM2M contact point. What is the container, if such device exists, and also the latest or the oldest. And here I can specify labels. If you remember, we have something like temperature. Let's see what are the labels here. Sorry. It's in the home building. Let's go there. I'm looking to, let's say, the luminosity sensor. Okay. So the luminosity sensor has this label. So I will use some of them. For example, device type luminosity.